going to do in this little 5-minute talk is try to touch on, if time permits, two of my favorite kinds of applications of collections. The first of these is the idea that, in fact, all the different taxonomic groups are in the game. So our existing data, in fact, is incredibly useful as it stands for talking about climate change impacts, if we do some modeling. And then the second theme there is the idea that one of our core products from our collections, phylogeny, is also extremely useful. So I'll touch on both of those themes. So that first theme, for me, goes back to one of my papers in 2007, which looked at this problem of forecasting. And it was an interesting skeptical look at whether we can do forecasting. Some of that skepticism comes through in this paper in terms of, well, really, how good a job can you do at forecasting? But the point here is that we finished on a very positive note. And what is that positive note? Well, the vision that came out of that paper was that museum collections, if combined with environmental and other data, can be a very powerful data source. And indeed, then we can examine scenarios of climate change by looking at shifting patterns that come out of our models. On the left, in this kind of hypothetical space, the yellow dots are the places that have already been sampled and exist in our collections. The red lines then are measured species differences among those collected sites. Well, that's great, but of course there are always the black dots, and those are the places where we have no collections. Well, on the right, in contrast, we have environmental data, and typically we can measure environmental differences among all of those sites. What we'd like to do somehow is combine that information. We can make predictions about the biological or the species differences among all our sites. That sort of multivariate modeling, many taxa modeling, is incredibly powerful. Now, initially the models don't include climate change as an element, as a factor, but in fact what we can do then is predict how those biological differences change from site to site. So the climate change scenario that we might examine, for example, one from CSIRO, will imply changes in those species differences between sites. And for a long time we've had the problem of, well, what do we do with that information? How do we turn that into something useful for decision makers? And some of my recent work, I think, has made a bit of a breakthrough in turning that into the corresponding measures of what we need. And those measures are the measures of actual biodiversity loss as a consequence of climate change. So on to my second topic, phylogeny. Well, phylogeny, of course, provides us with one of our fundamental measures of biodiversity, a measure called phylogenetic diversity, based upon my old PD measure. That measure is widely popular, not only for climate change impact studies, but land use impact studies and so on. So what I put up here is a simple study from Europe using PD for climate change to illustrate the flavor of these sorts of results. So that's the phylogeny. The length of the black line segments in that tree is the total PD that exists after the climate change scenario has driven some species to extinction under that scenario. Now, in this case, it was a good newspaper in the sense that it said that although about 2/3 of the species in that taxonomic group were projected to go extinct across continental Europe, less than 1/3 of the evolutionary history, or PD, would be lost. So that's interesting. On the other hand, look at the right side for you pessimists in the room. Take the same tree, and if we're unlucky and the same number of species are lost, but they're clumped, then in fact that same number of species lost can be a devastating loss of evolutionary history. One nice example on corals I've done with Zoe Richards, who many of you know, sees both sides of that sort of picture. We've got some good news and we've got some bad news. What's emerging from that research is a really interesting call for what I call phylogenetic risk analysis. So we approach these projections in a risk analysis way and try to relate that to good decision making. So to sum up my 5 minutes, I've given you an overview in terms of what other people using collections out there regard as the utility of those for climate change. And I've touched on kind of my two favorite contexts. And the reason I highlight those today is I think both of those contexts mean that everyone is in the game. Our existing collections, in a way, can become part of those models, even if those collections may have been sampled originally, collected originally for quite other purposes. And then secondly, to add to that, pardon me, one of our fundamental products from our collections, Phylogeny, has new and expanding uses. And so I think we're in a powerful position, in fact, for museums to play an important role in looking at climate change impacts on biodiversity. And I'll leave it at that. Thanks.